So today we're going to start looking at some basic differentiation rules. Now, at this point in time, we have been finding the derivative using the limit definition. So I'm going to look at an example that starts off with that. So with this example, I want to find f prime of x for the function f of x is equal to x squared. So just a basic derivative problem here. But we're going to solve it using the limit definition of a derivative. So that's your formal definition of a derivative, which states that the limit as delta x goes to 0 of f of x plus delta x minus f of x all divided by delta x is equal to your f prime of x. So if I plug this in, we have the limit as delta x goes to 0. The first part, I am taking x plus delta x and replacing that in the original x squared problem. So instead of having x squared, I will have x plus delta x squared minus, the next part says subtract your original f of x, so I'm going to subtract x squared, all divided by delta x. Now if I plugged in delta x is 0 at this point in time, I would end up with the indeterminate form, 0 over 0. So I'm going to have to simplify this. That means I need to multiply out the first set of parentheses here, so I'm going to FOIL that, which gives me x squared plus 2x delta x plus delta x squared minus the x squared at the end, all divided by delta x. And then from there I can start canceling out. So the x squareds will cancel out. And if I look at what's left over, a delta x will cancel from every term that's left, leaving me with 2x and a delta x. So if I rewrite this, I now have the limit as delta x goes to 0 of 2x plus delta x. And then I can evaluate my limit by plugging in delta x is 0. So I get 2x plus 0, which is just 2x. That is my f prime of x, which is the derivative or the slope of the tangent line. Now that's a very basic, simple derivative problem. But if I expanded this and made this into something a little bit bigger, let's say like x cubed, then that's a lot of work to go through, especially with the multiplying step in the middle here and simplifying, just to find the derivative at the very end. So this is definitely not the most efficient method for solving a derivative. And so that's where we're going to look at today is how can I actually solve these types of problems when I want this exponent to be a little bit higher, but I don't necessarily want to go through all of this algebraic step in the middle. So rather than give you the formula, we're actually going to see if we can come up with a pattern of where this is coming from. So I want to make a chart with two different columns. The first column is going to involve my function, and the second column is going to involve the derivative. Now, with the last problem that we just did, we looked at the function x squared. And we found when we took the derivative that the derivative went to 2x. If I continued this and I plugged in x cubed into that limit as delta x goes to 0 formula, I would find that the derivative, after all that work, goes to 3x squared. Same thing would be true if I had x to the 4th. It's a lot of work, especially as I'm plugging in the x plus delta x portion of it all. But after all that work, I would find that the derivative went to 4x cubed. So if you ask yourself, what's the pattern here? Notice all of these have the exponent being pulled out in front, and then it's decreasing in the exponent by 1. And so if I wanted something like, let's say, x to the 100th, well, if I had to plug that into the limit as delta x goes to 0 formula, that would take me a very long time. Now, it's not impossible, definitely could do it. You could even use Pascal's triangle to expand it out better, but it's a lot of work. So instead, knowing this pattern here, I can bring down the exponent in front and then subtract 1 from the exponent. This is known as the power rule in calculus, which states if I take x to the nth power, the derivative of that, which is your slope of the tangent line, would just be n times x to the n minus 1. I bring out the exponent in front, subtract 1 from the exponent. So we have 3 rules we're going to look at today. The first is called the power rule, and that's what we just wrote. And that says if I'm given y is equal to x to the nth power, the derivative, which is y prime, would equal n times x to the n minus 1. Bring down the exponent, subtract 1 from the exponent. Now a lot of times we may not just have an x, we may have a constant number involved with this. So let's say I'm given y is equal to a constant number c, where c could be 2, 3, -7, anything like that. Well, if I think about that on a graph, we're graphing a horizontal line at c, and the slope of the horizontal line is 0. And remember, a derivative is just slope of the tangent line. So then the derivative, which is your slope, would have to equal 0. So anytime I have a constant number, the derivative is going to go to 0. Most of the time, though, we're not going to have just a single term by itself. We're going to have other terms being added or subtracted to those terms. So let's say we have y is equal to, we'll call it f of x for now, plus or minus g of x. So I have 2 different terms, which we're calling different functions here, being added and subtracted, and I want to find the derivative y prime. Well, if I think back to limits, when I had the limit of 2 things being added or subtracted, I just found each one individually and added them and subtracted them together. Same thing's true here. I go term by term, and I would take the derivative of the first one plus or minus the derivative of the second one. Just go term by term throughout all of the problems. So now we can look at a couple examples here. So for this first one, I'm going to have a couple different parts to this. We're going to look at f of x is equal to 7. Now 7 is a constant number, and based on the constant rule, the derivative of a constant has to go to 0. And that would be my answer. Graphically, what's happening is I'm graphing y equals 7, and the slope of that line is 0. So then the derivative has to equal 0. So let's try another one. Let's say y was equal to pi. Now be careful, pi looks like it could be a variable, but it's not. Pi is just a number, it's 3.14. So then y prime is going to have to equal 0, since pi is just a constant number, and a constant number has a derivative of 0. Now let's look at one that's involving x. So let's say I'm given y is equal to x to the 5th power minus 2. Well, I have 2 different terms here, and so my sum and difference rule says I'm going to take the derivative of each one individually. So if I take the derivative of this x to the 5th, that's going to be the power rule. Bring down the exponent in front, subtract 1 from the exponent. And this minus 2 is a constant, and so derivative of a constant goes to 0. So I just end up with 5x to the 4th. So let's look at another one. So this one we are given f of x is equal to x. A little bit different here, because technically I don't see the exponent on the x, but we know it's an implied 1. So when I take the derivative, if I'm applying power rule, there's a 1 right here. I would bring down the 1 in front, so just be 1. And then if I subtract 1 from the exponent, that would be x to the 0. Well, anything to the 0 power is going to equal 1. Here's another way of thinking about it, though. If I'm looking at a graph of y equals x, that's our diagonal line going through the origin, the slope of that line is equal to 1. And remember, slope is derivative. So if I put this with a coefficient, let's say f of x was equal to 9x, then your derivative is just the slope, which would be 9. Basically, all that tells you is If you have a coefficient times x and we're taking the derivative, it's just going to be the coefficient because that's always going to be the slope. Now I could have a coefficient that's already there, so let's say we have y is equal to 5x cubed. Well, the power rule still applies. I'm going to take this exponent, multiply it in front, subtract 1 from the exponent. So in this case, if I multiply the 3 in front, it's getting multiplied with the 5, so that becomes 15 in front. Subtract 1 from the exponent to get 15x squared. But I do have to be careful because sometimes we're going to have problems that look a little bit more complex just because they give you a fraction or something like that. So let's say I'm given y is equal to 2 over x. At this point in time, we have no rules involving fractions or multiplication, anything like that. All we have is the power rule, sum and difference rule, and constant rule. So this means I need to get it all to one line where I have exponents. So I'm going to bring up the x as a -1 exponent. Then I can take the derivative using the power rule. So the power rule says bring down the exponent in front. So I have -2 now. X to the subtract 1 from the exponent. So if I subtract 1 from -1, now my exponent is -2. And you do not have to simplify it. We're going to leave it just like that. So let's look at another one. Let's say y was equal to 1 over 2 times the cubed root of x squared. Definitely need to rewrite this because I don't have a fraction rule yet. So if I rewrite it, I can pull out this 1/2 in front. So I'm going to make that 1/2 as a coefficient. X to the, and then it's always power over root, bringing it up with a negative exponent. So the power over root would give me -2/3. Now that everything's on the same line, I can apply the power rule. So I'm going to bring this exponent out in front, multiply those together. So 1/2 times -2/3 gives me -1/3. X to the, subtract 1 from the exponent, so I'm subtracting 1 from here. -2/3 minus 1 gives me -5/3. And again, I'm not going to bother rewriting anything. I'm going to leave it just like that. Okay, so next one, we have a couple different terms being added and subtracted here. So this one I'm given y is equal to x cubed minus 4x plus 5. So again, the sum and difference rule says just go through, take the derivative of each term individually. So y prime would equal the derivative of x cubed, I bring out the exponent in front, subtract 1 from the exponent. Based on what we did previously, the slope of -4x is -4. Again, that's an exponent of 1. Bring it out in front gives me -4 in front. And then if I subtract 1 from the exponent, this is now x to the 0, which means that's going to go to 1. So it's just the coefficient. And then your 5 is a constant, so that would be 0 for the derivative. But let's say I'm given f of x is equal to x squared times 2x plus 1. This is a little bit different. I don't have any multiplication rules at this point in time, and all I have is the power rule, constant rule, sum and difference rule. So I must simplify it before I can apply the power rule. The way to simplify it would be to go ahead and distribute this x squared. So this is equal to 2x cubed plus x squared. Once I simplify it, then I'm going to take the derivative. So now my notation changes to f prime of x because now I'm taking the derivative. And I can go through and apply the power rule. So if I bring the 3 out in front, 3 times 2 is 6. Subtract 1 from the exponent. Plus, same thing with the next one, bring the 2 out in front, subtract 1 from the exponent. There's my derivative. This is also true if you end up with a problem with division. So let's say that I'm given y is equal to 3x squared minus x plus 1, all divided by x. At this point in time, I do not have any division rules yet. So I'm going to have to go ahead and simplify. I can simplify by dividing everything by x, since everything is over one term. So 3x squared over x gives me 3x. If I divide negative x over x, that's just -1. And if I take 1 over x, I need to rewrite it so it's no longer a fraction. 1 over x is the same thing as x to the negative 1. You can also bring this up as x to negative 1 and then distribute, but then you're doing twice as many steps. So just go through and divide each term by x, and you'll end up with this. Then I can take the derivative. So that's going to change to the notation of y prime. The derivative of 3x is just 3. Negative 1 is a constant, so that goes to 0. And with the last one, apply the power rule. I'm going to bring the exponent out in front. So I have negative 1 in front, x to the, and then just be careful with your negatives. If I subtract 1 from negative 1, I'm now at negative 2. So those are your basic rules for power rule, constant rule, and sum and difference rule. Eventually we'll find different rules that involve multiplication and division, but this is all we're looking at today.